Here we are, it's Wednesday, June 14th. We are about 4 more nights away from a new moon. Weather has not been particularly promising the last couple of days due to a lot of atmospheric water caused by local evaporation primarily. By day in the morning we would get nice blue skies, but by the afternoon things would be clouding up. It's now 10 o'clock in the evening on the 14th of June. We're getting our last look at some of the Virgo galaxies as they head off out of view from the observatory, but they're still in the middle third of the sky. We've just made a hop to Messier 104, and I can see the core of it forming on the screen. Something may have happened to the sky. This is not a particularly good view. All we are seeing of Messier 104 is the core. This is pretty definitive. Messier 3, basically, this should be a great glowing ball of light. And we are resolving stars across the core at 256 flood. It doesn't cut it. This pretty much indicates that something happened to the sky transparency. From that initial view of Messier 61 where I could see the spiral arms vaguely in a ghostly-like manner. So I would say observing for tonight is off unless conditions change. That's actually a fairly decent view right there of 61. I'll give it a chance to fully form before we take a look at 104 and a few other galaxies that I wanted to review on the list. So there we go. One of my favorite springtime galaxies, Messier 61. Interestingly enough, there was one image I got of Messier 104 where you could see the bubble that surrounds the galaxy. Now, whether that was some kind of weird artifact or it just happened to be a particularly nice night, not only do you see the main part of the galaxy plus the dark lane that bisects it and the luminous cap above that, but there is something that vaguely looks like a bubble-esque, and it's hard to say, a distended bubble that encapsulates the galaxy. I can't say whether or not that's visible now, but we are getting a pretty decent view. There are a number of other galaxies that I wanted a bit ado to in the Comma Virgo group. Let's have a look at them too before we flip over and have a look at the Ring Nebula, both in color and in black and white. As the image generates, I'll let you know what Messier 59 spec is. We have a galaxy in Virgo, as I mentioned, magnitude 9.6, 5.3 by 4 arc minutes, 60 million light years distant. You'll find that most galaxies that are of the 10th magnitude and smaller have multiple of size in terms of their arc minute size. And if you want to get a sense of whether or not they are visible through a telescope or a particular aperture, basically what you have to do is you have to multiply the dimensions times itself, 5.3 by 4, that's 20. 20 is about 4 magnitudes in terms of the logarithmic scale. It means it's going to be about 4 magnitudes fainter in absolute average surface brightness than the magnitude of the galaxy itself. This is 9.6, so that means it'll be about a 13.5 magnitude galaxy overall in terms of its average surface brightness, which is probably, you want to add another magnitude on for scope reach in terms of stars, so that would be a 14.6, so you probably want a 10 to a 12 inch telescope to get a good view, a decent view of this galaxy. Let's see what my next one is. Okay, Galaxy Messier 49 is now assembling on the screen. It's getting very close to just being outside of the view from the observatory. I'll give you the specs on Messier 49 as the image formulates. 49, it's a brighter galaxy and a larger one. Wow, galaxy in Virgo, magnitude 8.4, but 9.8 by 8.2, 60 million light years distant. No specification on what type it is. I imagine it's probably a giant elliptical. 9.8, 9 times 8 is 72. That probably means 5 magnitudes fainter. So basically, because of the logarithmic scale that's used with magnitude. So basically, you once again have to have a 10 to a 12-inch scope to get a good view of this galaxy. Although it's quite obvious in smaller scopes as well, you just wouldn't get a sense of any frontier about it. It just looked like mostly like a large fuzzy star. So that covers 49. Okay, what I want to try with planetaries is a couple of things. First off, because their nebulosity. They shouldn't appear immediately on the screen. You should be able to watch them develop because of their nebulosity. So I'm going to look for that. One of the problems with planetary nebulae, although this one I think is pretty obvious in Corvus, is that they often just look like stars, and until you use a filter on them, you can't determine that the planetary nebula is a planetary star. This one's pretty obvious from what I can see looking at the screen. I'll give you the spec on 4361. The other thing I want to try doing is going into color mode and see if we can get any color out of this, because I suspect color mode works best with nebulae of any type, planetary and otherwise. So I'm going to give you the spec on NGC 4361 while the image is up there on the screen. But let's go back to a galaxy, now that I know for sure it's in day mode, and see if we get the depth of image that we were getting, because apparently it was in day mode for that. I am a bit befuddled why it would still be there. But as I said, it's very difficult to navigate using the controller itself. It does have a Rev2 imager itself. There is a hand controller that comes with it, but it does not function as well as I might like. And in this particular case, there may very well have been clouds floating overhead which obscured our images earlier on. So multiple variables always get complicated. So why not go ahead and switch back to 104 and have another look at that in color mode just for comparison purposes. Well, certainly it must have been something meteorological that was blocking the view earlier, because we are getting a fulsome view of the Sombrero Galaxy right now. And I do not want to try navigating again through the Rev2 screen in order to be able to do a comparison between the two views. But I would say whether you have IR optimization on or you have daytime mode, the views are comparable. The question is whether or not we're actually getting any color content in our views. So that planetary nebula we looked at earlier in Corvus, that was in color mode. Now I have a few other studies on my observing list for tonight that I want to go to, and then we'll take a look at the Ring Nebula as it begins to ascend into the sky's middle third. But from what I can tell right now, the views are comparable. Remember, we're at 128 flood now, too. I had pushed it to 256, and we were getting very poor views earlier. So I'm just going to stay with the 128, which is now pretty much my go-to setting. I am pleased with the view of the galaxies we got earlier at it, and apparently they were all in color or day mode. For whatever reason, it did not change after I changed it, and then when I bailed out and saved, it retained daylight mode. Okay, we've seen this galaxy before. It's Messier 64. I believe it's also known as the Black-Eyed Galaxy. It's in Gamma Berenices, magnitude 8.5, very large, 10.3 by 5 arc minutes, very close, 19 million light years. It's not as large as it might be. It's probably half the size, maybe even smaller than than M31, the Great Andromeda Galaxy, but it gives a very spectacular view. Look at the spiral extensions on it. I'm not noticing what, yeah, I think it might be the black eye. I'll have to look at it on the screen in the morning. Anyway, there should be a very dark bar that separates one of the spiral arms that gives it that black eye epithet. So Messier 64 is our current view. I believe we may now be doing an equatorial flip, but I'm going to go ahead and call up a few others. We've done all the ones that I think we're sinking out fast, but let's go have a look at Messier 83. Okay, as you can see, Messier 3 is now forming on the screen. I have yet to get a good look at its spiral extensions, but from what I can see, we're getting probably the best view we've had yet. I'll give you the specs on it. It's fairly large. I think it's probably even more so than Messier 64 was in terms of extension in space. And Messier 83. Galaxy and Hydra, magnitude 7.5. Yes, it is larger, 13 by 12.2 arc minutes, a little closer than 64, 15 million light years. So, even though it's magnitude 7.5, at 13 times 12, that's probably, the average surface brightness is probably somewhere around 14.5. And yet, we're seeing some really nice spiral extensions, even at the awkward angle I'm at. Look how huge this is. Wow, I did not get a view like this earlier. This is something that we should take a little time and keep on the screen. It's in Hydra. You can see separation of the various spiral arms with dark. Now remember, this is a face-on galaxy, so rather than calling them lanes, we'll just call them obscuration regions between spiral arms. The star, neighborhood of stars is actually quite interesting too in Hydra. Many real stars, most of those are probably 11th and 12th magnitude, the brighter ones. The image is coming out really well. Excuse me. Very, very pleased with this view of Messier 83. Whatever was blocking the transparency earlier is now banished from the sky. Messier 5, from previous observations, is a very large cluster. I think it's about 19 to 20 arc minutes in size. I'll go ahead and give you the data on it, but this is not the best view of it because you really should run the exposure times down. But just for the record, Messier 5. It's a globular cluster and serpens, magnitude 5.7, 19.9 arc minutes, 24,500 light years distant. And to give a good view of this, we probably have to drop it down to about 16 to 32 flood. 5846, Galaxy in Virgo, magnitude 10, 4 by 3.7 arc minutes. It's an elliptical at 79 million light years, so I was a little off on that. Elliptical galaxies generally do not present much in the way of texture, so they're less interesting than spirals. But they deserve attention because they're very mature galaxies with much of their cold dark matter converted to stars, typically as a result, in my estimation, of collisions that have occurred with other galaxies, such as our galaxy colliding with Messier 31, the Great Andromeda Galaxy, in the future. It's a fairly bright galaxy, 5850, Galaxy in Virgo, magnitude 10.8, 4.5 by 3.9 arc minutes, 107 million light years distant. Spiral with a large bar, a little capital B and an AB. And you can definitely see the spiralicity, the arms going off this kind of an angle. Large core. Should look better on the screen. Still got some power left. 3 bars actually on the camera. At summertime, the battery signal do last longer, which is a little bit foreboding when it comes to EVs, electric vehicles, in the wintertime in terms of the battery life and mileage that you might get out of them. Let's look through a few more. There's a magnitude 14 Galaxy 5851. It's a 1 arc minute size, 0.3. It's in Buutes. Why don't we go there, since I've got some battery life left. Watch it formulate on the screen. Remember, this is 5851. I'll give you some information on it. I hope you've been watching, because I haven't been able to, but there does appear to be a bit of an edge-on spiral right there at the tip of my finger, looking at the screen. NGC 5851, Galaxy in Buutes, magnitude 14, 1 by 0.3 arc minutes, a spiral with a lowercase c, 296 million light years distant. I suspect that it probably is a little smaller than our own galaxy. At this distance, 296 million light years, I would expect the Andromeda galaxy to be about 2 arc minutes in size, or very close to it. So we're talking about something about in the 75 to 80,000 light years in diameter size. Have to do the math on that to confirm it. Yeah, that is a pretty obvious edge-on spiral. Very nice. Well, got all kinds of streaks on the screen. They'll have to fade out. Let me start reactivating the camera. I'm not seeing anything yet that paints like a galaxy, except maybe there. But what we want to do is watch something develop, because that's the only way to tell that you're actually seeing a very faint galaxy, is how it slowly makes its apparition. Screen image still isn't regenerated because I'm still seeing streaks. I'll give you the data on NGC 5855, and that'll be it for adventitious galaxies for the evening. NGC 5855, Galaxy in Virgo, magnitude 15.5, 0.7 by 0.7 arc minutes, a compact galaxy, some 474 million light years distant. Half the distance of the most distant galaxy I've turned up yet. I can't tell you what its NGC was, but I know it was some 978 million light years distant. I'm sure this one's turning up somewhere on the screen. It'll be easier to determine on the manana, but I'm seeing some faint fuzzies right about there. 474 million light years distant. Let's start with the 2-inch view right there. All right. 2 flood is roughly equivalent to a 2-inch scope. I'm not seeing anything of it. Should be able to see it in binoculars, however. Now we're up to 4 flood. I'm not seeing anything. 8. Okay, the nebula is starting to become visible at 8. Go back to 4. Not seeing it. 8 flood. All right, here we go. So clearly we can all confirm that that's the ring nebula in Lyra. Starting to see more. We're at 6-inch setting right now. I couldn't tell you whether the central star is apparent. Maybe. We're certainly seeing some texture in the nebulosity. We go up to 32 flood. Now we're talking like an 8-inch scope. We're starting to see the nebulosity within the ring itself. However, we're starting to overexpose the outer ring. If we go to 64, pushing it. Okay, now we're starting to lose it. So if I can find a corresponding button on the other side, okay, we don't want that. 32 flood. All right, there's probably our best view. 6-inch setting. Oh yeah. Now, is there any color? Couldn't tell you. You're gonna have to wait for the dumbbell for that. So the 6-inch setting is giving about the best. Now we've been through this step through before with Messier 3, which is a more brilliant globular cluster than Messier 4. Now, right now we've got the 2 flood setting. The sky is good. Dark. I haven't done it this well, done it under these conditions with Messier 3. But you can see it's not easy to determine the fact that we've got a globular cluster in the screen right now. All right, now what I'm going to do is I'm going to step through it. We're starting to see some star formation there. It's not until we get to 8 flood that it becomes clear that we've got a globular cluster on the screen. That happens probably at 4 flood with Messier 3. We keep stepping through it. Now we're up to 16 flood, which is basically a 6-inch scope setting. One of the things most people notice about Messier 4 is this bright band of bright stars right across bisecting the core. Let's push it up to 32. Now we're starting to get a little more glow in the core. If we give it a chance, those stars should tighten up. Look a little less bloated. But that's not a bad view. Here is our reference globular cluster for determining basically things that have to do with other globular clusters. And one of the learnings that came out of it is that we have a lot of cold dark matter that it's basically absorbing a lot of light from more distant globular clusters than Messier 4. Messier 4 is only about 7.2 thousand light years distant. I'll go ahead and give you the spec on it, but it makes for a very nice reference for determining the actual absolute diameters of other galaxies based on its size, as well as their relative brightness. What the database here has to say is Messier 4 is a globular cluster in Scorpius, magnitude 5.4, large, almost as large as the moon, 26.3 arc minutes, 7,200 light years distant. That's the view we get. We probably have a washed out core with Messier 13 and with Messier 3 at 32 flood. So I am going to leave you with this as the Carpe Noctem moment.